So my topic for today is inside the PBXT storage engine, PrimeBase XT, same thing. My name is Paul McCullagh and I'm working for PrimeBase Technologies. So content looks short, but there's actually a lot to it. I'll start with describing the design of PBXT and explain how it works. And then we'll be looking at some of the applications of the design, which is very flexible, in particular SSD drives, and how we can leverage this design for an HA solution, which I see as the future of PBXT. This will be one of the distinguishing factors of PBXT as we go forward. So PBXT is pluggable. It's a pluggable storage engine for MySQL 5.1. And by pluggable, I mean it's dynamically loadable by MySQL 5.1. In fact, I have binaries on the PrimeBase website, so you don't necessarily have to compile if you're using Linux, 32-bit Linux, or 64-bit Linux, or Windows. Those are the binaries I have which work with the binaries from the MySQL website directly. It's transactional and ACID, fully ACID compliant as of version 1.0. The previous versions of PBXT were not fully durable. I've fixed that. It's an open source project. We belong to the community and we're proud of it. So PBXT was designed and built specifically for MySQL, and so it's not a retrofitted engine which has been adapted for the MySQL environment. This makes it quite efficient in in a lot of ways, but it also made my job a heck of a lot easier. This is our sponsor. It's an open source project, free for everybody, and that's where it's hosted. So you can, with SVN, you can download the bleeding edge, try it out. So what are the basic design principles behind PBXT? Well, first of all, it's MVCC based, which is multi-version concurrency control, which we have Jim Starkey to thank for that. He's not here, but Anne is. And it's really the way to do things in databases today. But there's a difference here. We store all versions on disk. So Jim said that's not a good idea, but I'm doing it anyway. We'll see. The main design of PBXT is log-based, and what that means is a large majority of the database can we can get away with what I call write once. I write the data once to this log-based system, and I'm done. And sequential, of course. PBXT also never updates in place, so it's creates new versions somewhere else. This has some interesting consequences, which we'll discuss later if there's still time. It doesn't ever undo an update, so non-committed data is identified as garbage and it's just cleaned up in the background. It's file per table based, there's no table spaces, so in that way it's similar to MyExam. This has, I think, some advantages. Maria is also table based in the same manner, so I think Monty agrees. So if we look, Monty says, so if we look at the structure of PBXT on the disk, this will give you an overall idea of what's there. And we create a table, something like this, and insert then a bunch of rows. And you have a look under the var directory, or the data directory of MySQL, you will see, besides the MySQL directory, I haven't put that in now, there's a directory, as you know, there's a directory for every database. And then I create a PBXT directory, which is not a database, so might be, but MySQL thinks it's a database, but this is the best way for me to do things, so you can link it somewhere else. Anyway, if you look under the test directory, there's actually 4 files with which start with the name notes. So these all belong to the notes table. The first one here is the XTR file, which includes the ID of the table. PBXT issues a unique ID to each table and stores it in the XTR file name. This is called the row index file. The .frm file is familiar to most of you. I'm sure it's the format file that's created by the MySQL server itself. And then we have an XTD and XTI file. The XTI file contains all the indexes of the table. That's very similar to the way MyISAM works. And the XTD file is called the handle data file, and it contains 2 things, a bit of data and a bit of control data. And I'll be describing that in a minute, exactly what's in there. So if we look at PBXT directory, there's 2 subdirectories, data and system, and a file called the location file. And in the location file are the paths of where PBXT has to look to find its tables, which could be spread over a number of databases, over a number of directories. It stores those locations here and maintains this table. It's a text file, so you can look in there, but you shouldn't modify it unless PBXT's made a mistake and can't find its tables for some reason. Okay, so in the system directory, there's the transaction stuff. There are the transaction logs, which have a sequential ID, which is incremented at the end. When PBXT creates a new file, it increments this ID, and when it deletes an old one, it will usually recycle that old one, but it'll get a new ID. And then there's 2 restart files, which contain the recovery points, and PBXT writes them alternatively, so one is always valid. And the data directory contains the data log files. These are the files that contain then most of the database, and we'll be looking into that in a bit more detail in a minute. So the best way to describe PBXT is to go right down to the bottom and have a look at the record structure of the table. And so you can see the records of PBXT records are divided into 3 parts, a gray bit and a light blue bit and a dark blue section here. But seriously what there are is this gray part. First of all, these 2 components together are fixed length component, and they're stored in the handle data file. And this is the extended part of the record is a variable part of the record that's stored in the data log file. And the part of the handle data file is divided into 2 components, a fixed length piece of data and this control data here. And what's in the control, this is a header here, that's important. This is a complete list of what's in there. First of all, 2-byte status, a pointer to the previous version of the record, this is MVCC, the transaction ID, so we can identify which is the most recent record, or which is visible more accurately, a row ID, which I'll get to in a minute, and a reference to this extended data here in the log. So this is where the handle part gets its name from. This is actually a handle, and when the data log record moves somewhere else, this can just simply be updated to point to the right place. So this is actually, the control data is maximum 26 bytes long.